Hey guys, right now what we're going to do is because we've been working so much with functions and describing them and composing them and finding their inverses um, and studying 12 basic functions, we're going to actually let our knowledge of functions help us to analyze some real world data. So what I've got in the 1-7 note sheet over here are the winning times in the men's 100-meter dash at the Olympics since 1972. What we're going to do is get that data information into the calculator and then take a look at a graph, a scatter plot of it, which would be easy enough to do by hand, but the calculator can do it for us. And then once we have that, we're going to talk about how we can have the calculator run a couple of models for us, depending on what kind of function we think it might be a good fit for this data. So the first thing we're going to do, because we have some information, some data, some statistics, we're going to hit the stat key. And as you hit stat, you get this menu over here of edit, calc, and stats. In this class, we're going to use edit and calc tests you would see if you were to, say, take an AP stat class. So as soon as I hit the edit menu, under the edit menu, we want to choose edit. So I'm going to hit enter right there. Now, I've taken the liberty already to gone ahead and entered this data in list one, the years since 1972, or I'm sorry, the years since 1900. So 72 corresponds to 1972. 100 would be 100 years since 1900 or the year 2000, all the way down to year 116, which is 2016. Scroll over to list 2, and I've entered 10.14, 10.06, and so forth in all these. And that's very straightforward. It's exactly what you think you do. Just hit the number and hit enter, and it'll take you to the next cell. So you didn't want to sit here and watch me do that, though. I do want to mention, though, some of you might have calculators that already have some data in it. If you ever need to get data out of a list, like, for example, I have these few numbers in list 3, go over to the list that you want to clear out and scroll up to the top and hit the clear button and then hit enter, and it clears all the data from that list. You can also sit in the top cell and just keep hitting delete, and it'll delete one cell at a time until it's all gone, but it's much better to do that. One caution, though, don't go up to the top and then hit delete. If you do that, it's literally going to delete the entire list, so that, for example, in list 3, if I hit delete, it'll just disappear, and I'll have list 1, list 2, list 4, list 5. If that ever happens to you, or if you look on your calculator, it's already happened, you can go back to stat and then go down to setup editor and just choose option 5, and that'll bring back all of your list, 1, 2, 3, and so forth. But now that we're back at our data, you can see that all the data has been put in there, and you want to make sure that as you do this, everything's very accurate. If one of these numbers is off, or if you put 2 entries in the same column or something like that, it'll screw everything up. So carefully enter that data. And now what we want to do is get a picture of it. In order to get a picture of this data, I want to have the calculator know that we're going to do a scatter plot. So we're going to turn our scatter plot on, and by do that, you see above y equals, it says stat plot. So I'm going to hit second y equals, and it gives you these options for stat plots. And if you want to change the settings or the mechanics of any of the stat plots, you hit enter, and now I'm in plot 1, which is highlighted, and right now it's blinking that it's on, and the on blinking thing is highlighted. If I wanted to turn this off for some reason, I'd scroll it off and hit enter, and now the data would still be in my list, but I could access it as needed, but it wouldn't be trying to graph it. The next line down is all the different types of scatter plots we can create: bar graphs, connected dots, box and whiskers, things. So this first option, the scatter plot, is fine. So we're just going to leave it right there. XList L1, what that means is your x-axis on your graph is going to use the data from L1, and the y-list being L2 means the y-axis is going to graph, in this case, the data that's in L2, which is our winning times. The mark, I would choose the mark that you're going to use is what's going to show up on your graph. I would either use the box or the plus. Your screen's pretty small, and if you use these small dots, they just kind of blend into the background, so they hardly make any difference. Now, the next thing we want to do is check our window, which is probably for you guys set at -10 to 10, or whatever. Maybe you had some settings for some problem we did in class. But since our times go from 1972, which is the year 72, up to 116, I set my x min at 72. So all you do is just put in 72 and hit enter. My x max at 120. That would be up to the next Olympics in 2020. My scale, X scale, is set at 4 because I've got data points every 4 years. And now my Y min, the lowest time we have is 9.81, or I'm sorry, is 9.64. So 9.5 is probably pretty good for my Y min. That Y max of 10.5, you could see why I chose it because I've got times up here at 10.25. I think I'm going to take that to 10.3, let's say. Maybe not all the way up to 10.5. And my Y scale is how often I'm going to see tick marks on the Y axis, and every 10th would be good. So I think we're going to be in business there. Now when we hit graph, we're not seeing our scatter plot. You know why? Because when I went and showed you how to turn it off, I never turned it back on. So I'm going to show you the hard way to turn it back on is come all the way back in here and hit enter on the on. And now when I hit graph, it'll be there. There's all my data points with the times generally trending downward over the years. You can see this little guy, the very last time, 9.81. I don't know, probably a lot of you guys may have even watched that race. Usain Bolt just kind of got off to a slower start than normal and wound up winning the race, but not one of his best times because he won in 2008, 2012 with these 9.6 times, 9.69 and 9.64. This other data point that's up here, 1980, 10.25. I started to talk about this a little today, and I just didn't recognize that data point was so unusual. And I don't know why I didn't notice that because I remember that year clearly. I was 7th grade back in then. And it might be a good idea for you guys to go Google what happened in the Summer Olympics in 1980. They were held in Moscow. And if you just Google that story, just Summer Olympics Moscow 1980, and see if there's anything about that story that you might find that might indicate why that time is so slow. Might be an interesting little story for you guys. Anyway, there's our data. What we're more interested in is finding a function that would sort of model this data. Now, you may have done in Algebra 1 something like a line of best fit, where this stuff is coming down here. We can certainly do that. The calculator is well designed to give us a function that would be the line of best fit. So let's maybe try that now. We hit the stat key, and we want to now go over to calculate and use the calculate menu. And what we see here is this one var stats, one variable stats. That's going to give us some information. We're not going to use that now, but that would give us information about the mean and the median and stuff like that. What we're going to do is go down to option 4, which is linreg, which stands for a linear regression. And a regression is, if you know what it means to regress, it means it's going to go backwards. What that means is you're taking data and going backwards and trying to figure out an equation that would fit that data, rather than having an equation and plugging in some numbers and getting outputs. So we're kind of working backwards. We have the data, but we don't have the equation, so we're going to go backwards. So to get a linear regression, I'm just going to choose option 4. And it's asking me, now your different calculators have slightly different menus here, but basically it's just confirming that we want to use the list 1 as our X list and list 2 as our Y list. Frequency list, I don't even know what that means, to be honest. And all we have to do is just kind of go down here and hit enter until we get to calculate. And once we do that, it's going to calculate our linear equation. And what it's doing is saying it's basically y equals mx plus b, but they use a instead of m. And so it's telling us that the equation that would fit this data best is the equation y equals negative 0.01075 x plus 10.92899. Great. It would be nice to see what that equation looks like with our graph. But I'd also like to know how good a fit that is. And so some of you on your calculator right now might have an R value here. It might say R equals, and then it would have another value that says R squared value. And it would have some decimal numbers in there. And I want to make sure that everybody knows how to get those values. Obviously, mine doesn't have it right now. So I'm going to go turn mine on. And if yours does not have R values here, you can follow along with these steps. If it does have R values, you're fine. You can just kind of fast forward through this. You won't miss anything. So I'm going to get those, what's called the correlation coefficient up there. So I'm going to hit second catalog, which is second 0. And I want to go to diagnostics. We want to diagnose what our data look like. And to do that, right now I'm in alpha mode. You can see the A up there. So I just want to hit the D, which is the matrix key with the X inverse. And if I scroll down now, in the D's, these are all the different features that the calculator has. I want to go to diagnostics on. So I'm going to hit enter. And now diagnostic on is on my screen. I just want to hit enter to tell the calculator to do it. It says it's done. So now when I go back to hit stat and calc and option 4 linear regression and hit enter down at calculate, notice I get not only the a value and the b value, in other words, the slope and the y-intercept, but I get r squared and r. And basically what's happening is the r being a negative value is basically telling you that this has a negative trend, like a negative slope. As our time increased, our winning times decreased. As the number of years since 1900 increased, this negative here is indicating that the trend is downward. R squared is telling you how good a fit our data points are going to be toward fitting perfectly on the line. Now, an R squared value of 1 would be that literally every data point fits exactly on the line. Our R squared value of 0.7766 is pretty crappy, to be honest. That's not a very good fit. I think in the world of statistics, they want to see the R squared value somewhere around 0.85 or something like that. But basically, that number right there, R squared, is telling you how good a fit your data is. So we might do another regression a little later and get it and look at that R squared value. And if it's a number closer to 1, we can say it's a better fit. So back to our graph here, you can see the points, but you can't see the line, the linear equation we just have. So what do I want to do is go to y equals, and I want to put that equation in there. Now, you could just type it. If you had it written down, you could just copy it from your typing, but I want to show a cool way that you can copy it from the calculator's memory. And what we're going to do is hit the VARS key, V-A-R-S, right over here underneath the down arrow. And when you do that, you can scroll over to Y-VARS. And what we're going to do, I think it's Y variable equations. I think that's what it stands for. And we're going to choose function. And what we're going to do is, oh, geez Louise, I did this wrong. I was going to copy Y1 in there, but I just remembered our function's not in Y1. So in order to do this, I want to go to VARS and go down to statistics because we've already run the regression. Sorry about that. We're going to go down to statistics and go over to equations, EQ. And that regression equation right there, that first item, if we hit enter now, what it's going to do is drop in the equation we got with all of its decimal accuracy into our Y1. Now the key is you have to be sitting in Y1 when you go do that. Otherwise, it's just going to drop the equation on your regular screen. But now if we hit enter and we hit graph, what you'll see is our line of best fit going through and doing a pretty crappy job of fitting the data. So there's one example of how we have a model. I don't think it's a very good model, but we have a model for our data. And I might ask you why, and I know it's on the note sheet. I think I asked, do you think a linear equation is a good fit for this data? Regardless of the correlation coefficient, that R squared value being 0.77 or whatever it was, is that a good fit? I would say no, and for a couple of reasons. So tomorrow in class, we'll talk about what reasons those might be. In the meantime, maybe when I go back to Y1, maybe I'll go over and let's see if I can change that color just because, let's see, I don't know how to do this. Oh, I know what I would want to do. Scroll back up here and then maybe go down. No, I don't know how to do it. Oh, well, I'm not going to worry about it right now. So I'm going to second quit out of that. What I want to do now is see if there's maybe another equation, a type of equation that we could do that would fit this data. And what I'm thinking is the times went down a lot in the beginning, except for that 1980 year. They went down a lot in the beginning. And then they were kind of slowly kind of like leveling off here. So maybe we'd be looking for something that could come down like this and then maybe level off. And if you think about that, that might be like an exponential decay function that might, kind of this downward leveling off trend to it. So let's maybe do a couple more things. Let's go to our data, stat, and edit. Because 1980 was such a funky year, I'd like to take that data point out of there and just kind of toss it. Now, you just saw me trying to scroll down. It's not letting me scroll down here because there's no data here. What I want to do is get over to list 1 and list 2. So I'm going to scroll up, then go over to list 1 and go down to 1980 and just delete. And it's taken that data point out of there. I'm going to do the same thing for the corresponding time of 10.25 that went along with 1980 and delete that data. I don't know. I feel kind of like we ought to delete Usain Bolt's 9.81, but we'll leave that one in there. Now when we do our graph, we still have our line of best fit. We've got that bad data point out of there. But notice that's still the same line from before. If we go back to our regular screen and we do another stat calc linear regression for number 4, choose number 4, and hit enter, 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 we get a new regression, which has a different y-intercept and a different slope. Now when we hit y equals, we're going to clear this old regression equation out of there, and we'll drop in our new one. So again, we're going to go to vars, down to statistics, option number 5, over to EQ for equation, and choose regression equation number 1. Hit that in there, and we'll see that guy. Now, I didn't notice, I didn't take a look at the R squared value, but I bet it's a lot closer to 1 now. I'm sure it's not very close to 1. Let's see, if I hit second enter, I can bring up the last thing I did. That's the linear regression. Hit enter. See that R squared value jumped up from a 0.77 to a 0.83. Now that's not too bad. Much more reasonable. But now I want to think about that idea that I talked about of maybe having like an exponential decay, where I think you agree that if this thing was linear, think about 20, 30, 40 years from now, as a line goes down and trends, eventually it would get to 0, get to a y value of 0. And I'm pretty sure nobody's going to be running the 100-meter dash in 0 seconds. So it'd make a little bit more sense to have it level off, maybe like a horizontal asymptote. So let's go back to stat and over to calc, and we'll explore these other regressions that we have. And as you scroll down this list, the number 5 is a quadratic regression. We've got a cubic regression. We've got a quartic regression. That would be a 4th power polynomial. Linear regression in a slightly different form than number 4. That one you'll use if you ever take AP stats. This LN regression, that's logarithmic. So we will probably use that before the end of the year. And here it is at option 0, exponential regression. That's the one I want to do because I think that's going to give us like an exponential decay. So when you choose enter on that, and again, I want to use list 1 and list 2. So I'm just going to hit enter, 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 and calculate. Oops, let's do that again. I hit enter too many times. There we go. And look at this R squared value. Not very different from our linear that we had. It was about 0.83 as well. Notice the template for the equation, though. It's a times b raised up to the x power. So our base b is 0.999, which basically means that each year you're getting about 99.9% of the time that from the previous year. But we can do the same thing, what we did before, and take our linear regression and clear that guy out of there and go to stat, down over to, go to vars, go down to statistics, option 5, and then over to EQ and choose our regression equation. And it just dropped in our exponential decay model. And if I hit enter on that, go and see the graph. And you might say, well, that certainly looks linear to me. And what's happening is it's just not decaying very quickly. So we're not seeing that swooping behavior that we could see. I think what we might want to do is, I think I do want to get rid of that other Usain Bolt data point. And I want to do one more thing while we're at it. So let's go back to our stat edit. And let's take 2016 out of there. So I'm going to clear, I'm not going to clear, I'm going to hit delete. And then I need to do that over here at year 116 as well. Delete that entry. Now hit enter. second quit, and if we come back here and I hit second enter, I can probably get that exponential regression to run again. Ooh, look at this, R squared value 0.9179, so we're way better than we were before because of that kind of blip. We were trying to have the data account for, or I'm sorry, have the function account for data that just didn't really make a whole lot of sense. Obviously, if we did our linear regression now, it might be a little bit better as well. But let's go to y equals, clear this guy out, and let's go back and pick it up from vars down to statistics, number 5, over to EQ, and have it drop that equation in there and hit graph. And there we go. Now, again, that may look pretty linear, but what we could do at this point is say, all right, let's see what's going on here. If we were to take a look at our window, and rather than stopping at 120, the year 120, which would be 2020, what if we go out to like, 2050 or even later? Let's go out 150 years and see what our graph looks like now. Should be able to see that thing curl off, not too much. Was kind of hoping to see it curl out there and get a little bit lower like that. If we zoomed way out, we would see this thing eventually come down. But what's preventing that is this 0.998 as our base. It's basically taking 99.8% of the time of the year before and just reducing it by whatever, like 0.2%. But I do want to do one more thing with you guys before we call it a wrap on this thing. Let's go back to stat, where we have all of our data. And what if we said, yeah, I see these times coming down to 9.64. What if we said we just don't think anybody is ever going to get below, say, a 9.5? Let's say that's like the lowest somebody could ever go with this thing. So I'd kind of be curious about comparing the times to what a 9.5 would be. In other words, saying that's the lowest we can ever go. So we'd be coming down and kind of leveling off at 9.5. So what I'm going to do is go over to our third column and go up to L3. And what I can do is actually just take our times from L2 and subtract 9.5. And it's going to be how far is that time away from 9.5. So what I'm going to do is go up to L3 where it's highlighted up there. And I'm just going to choose L2 by hitting second L2, and you see it appear down here. I'm kind of writing a formula now, kind of like you can in Excel if you've ever used Excel. And then I'm going to subtract 9.5. And what it's going to do is take all these times in list 2 and take 9.5 away from them and put those new kind of times in L3. So what we're doing is kind of comparing our difference from 9.5. And now I'd be curious about an exponential regression on these times and seeing what that looks like. So although I can certainly do an exponential regression on that, I want to first kind of set our window up. Looks like our window, the lowest time we go like from 0 to maybe 0.7. So let's say our window now is, instead of 9.5 to 10.3, let's go from 0 to, what did I say it was, about 0.64, so let's say 0.7, and we'll go by 0.1s. Now, if we hit graph now, we're not going to see much because our scatter plot that's stored in there is still the one that's comparing list 1 and list 2. And now we're interested in comparing list 1 and list 3. So I'm going to hit second, y equals, and in this plot 1 that's turned on now, I'm going to hit enter. And instead of having L1 and L2, I want to change L2 to L3. So I scroll down here, and I just want to take L2 out and replace it with list 3. So list 3, you'll see right there is the second 3 button. And now my scatter plot will be plotting L1 in my x-axis and L3 in my y-axis. We can go from there. So I'll see a graph now. We should be able to see it. And there's my times coming down. Let's go back and do a regression. And we are going to do, let's see, stat, calc. The exponential regression is option 0. And we're going to use not list 1 and list 2, but I want to change this to list 3. and then hit enter, 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 calculate, and there it goes. Oh, and look at our R squared value. We took it on the chin there. We went down a little bit. We're not even as good a fit as we were before. But if I go to y equals, I can clear out this old regression equation and hit vars down to statistics, over to EQ, and drop that regression equation in there and hit graph. And it's trying to, oh, but boy, you can really see that regression equation now showing up as having that times kind of getting closer and closer and closer to 9.5. So what might be interesting with this is the last thing we need to do before I set you free, which is let's see if we can predict a time now. And let's see if we can predict a time, say, in the year 2000. So the next Olympics are in 2020 in Tokyo. I think I said 2000 before, 2020 in Tokyo. So if I wanted to find out what the time is going to be in 2020, all I have to do, because I have my regression equation in there, is hit second, calc, and then ask it for a value, the y value. So just hit enter, and I have to put in 120. And what it's going to do as soon as I hit enter is the cursor is going to blink right on the spot, and it's going to say in year 120, it's going to be a 0.15. Now remember, that was a predicted difference from 9.5. So that means it would be 0.15 for greater than 9.5, or in other words, a 9.65. So there it is. You can store this, see what happens when you're in 2020 and you're in Tokyo, and see if the winning time is a 9.65. And then you'll say, hey, we predicted that back in 2016. What's also cool, though, is we could say, hey, let's now find out what the time is in, 2000, let's see, 2020, 2040, which would be 140 years away. So if I put in a 140 now, the cursor is going to jump over to 140, and now we're only at 0.08 seconds above 9.5, so it'll be a 9.58. Now, let's say, oh, let's have fun. That was fun. Let's see what's going to happen in the year 2100. So if we do second calc now, and we want 2100, which is 200 years since 1900, and we hit enter on value, and we put 200 years since 1900, we're going to get an error. And the reason we did is because our window is only set to go up to I think it was 150, which would be the year 2050. And we just asked it to figure out something that's happening in 2100. So in order to fix this, we would have to go to, and then what we can do is, right now it's telling us you can't have a 200 there. So I can clear that out and hit my window. And now if I hit my X max to be 200, or even 250, now I can put in any X value up to 250. So I can do second calc value and put in 200 now. I didn't get those 200. There we go. So this would be the year 2100, and it's predicting a 9.501 would be the time that it's predicting there. So who knows what the lowest any sprinter can go. But that's how you can work with this data. And we did a linear regression. We did a exponential regression. We showed how to delete data from lists. We showed a little bit of how to add data to lists. Delete a couple of individual pieces of data from a list that already had data in it. How to drop the equation into y equals without having to retype all this stuff. That's really convenient. And then last thing, again, I'm not sure if I mentioned earlier, if I want to turn this plot off, I can just be in the y equals mode, scroll up right down to where plot one is highlighted and blinking, and hit enter. And now you'll notice that when I scroll back down, it's not highlighted anymore, which means when I go back to my graph, those scatter plot points aren't going to be there anymore. The data is still in the calculator, it's still stored there, but it's not showing up every time. So generally, when you're in y equals, if you see these plot ones, plot two, plot three that are highlighted, you want to have them turned off unless you're actively working with them. You just don't want your calculator trying to graph data that may or may not be there. All right, guys, tomorrow we're going to do something cool in class. I want you to think about some data that you might be interested in that is changing over time. and that could be anything. It could be I can't imagine you're too interested in the price of gas, but the number of passes that are thrown in an NFL season, the number of Broadway shows that are on Broadway running right now, anything that changes over time. As long as you could get data on that, I want you guys to come in with data that has changed over time, whether it's changed over years or months or weeks or whatever. But I want you to have a good chunk of data, like at least about 10 data points. And what we're going to do is run some. You guys are going to run your own experiments with this stuff. So come think about that a little bit. Anything that's changed over time, anything numeric that's changed over time, and that you can get access to data with. And that is all you need for your homework. And tomorrow we'll have some fun in class. Thanks, guys.